Okay, so for the next part, okay, still line integral for scalar field, okay. But then what if we have if C, okay, the curve is piecewise smooth curve, okay, means that curve C, okay, is made by joining a finite numbers of curve, okay. So it's gonna be we can we can name it as C1, C2, okay, until the end, okay. So on how can we evaluate that line integral? Okay, so the line integral, okay, for the piecewise curve, okay, is gonna be the sum of the integral over the curve. Okay, so it's gonna be like this. Okay, so it's gonna be similar as what we practiced in the previous videos. Okay, we're gonna solve the line integral for each curve, and then we're gonna get the sum for each integral involved for that piecewise smooth curve. Okay, so for example, if you have this example, okay, the question asks you to evaluate this line integral where C is the line segment from this point to this point. So this one's gonna be C1, okay, and then from this point to this point, so it's gonna be another line segment. Let's name it as C2. So in this case, because just involve we would say that is involved with 3 points, okay. So for example, just we put it like what I'm supposed to say, we represent in a straight line from one point A. Let's name it as A, B, and C. So B and then C. So what? A to B is going to be one curve. B to C is another curve. Okay, so this is just how we try to represent it graphically. Okay, it doesn't mean that it's in a correct position. So I just try to draw like this so that it will be easy for you to understand. Okay, so in that sense, okay, so now we're gonna solve like this. So it's gonna be for x power of 3 ds. Okay, so now C is the sum of C1 and C2. Okay, so let's solve curve by curve. Okay, so let's name it as part A. Okay, for C1. Okay, so for C1 over here, okay, so it's gonna be line segment, okay, from point 1 to -3 to -1, -2, 1 over here. Okay, so from here, okay, so from here you're gonna get that x is equal to, okay, 1 minus 2t, y is equal to 2 minus 40, and z is equal to -3 plus 40. So if we solve it, if we find the derivative, so we're going to get -2, y prime is -4, and then z prime is equal to 4 over here. Okay, so we get ds. Okay, so it's going to be -2 squared plus -4 squared plus 4 squared dt over here. So you're going to get 6 dt. Right? Okay, so from here, okay, don't forget to check for the limit for t. Okay, so just keep that one. Okay, so you can check it by your own. Okay, but then the limit for t for this one is going to be from 0 up to 1. Okay, based on this one and the point. Okay, so we have get for this one. So the original question is C1, right? So next name it C1 for x power of 3 ds over here. So it's going to be 0 up to 1 over here. 4. So x equal to 1 minus 2t, right? To the power of 3. And ds equal to 6 dt. Okay, so if you solve this integral, you're going to get 0. Okay, so for this part. Okay. So let's move to second curve for C2. Okay, so now it's a line segment from -1, -2, 1 to 0, 4, 2 over here. Okay, so for this part, okay, the parametric equation would be x equal to -1 plus t, y equal to -2 plus 6t, and z is equal to 1 plus dt over here. Okay, so you're going to get x prime is equal to 1, y prime is equal to 6, z prime equal to 1 as well. Okay, so from here, okay, we're going to find ds. Okay, similar start. It's going to be 1 squared plus 6 squared plus 1 squared dt over here. So you're going to get square root 38 dt for this part. Okay, so you need to check the what I'm supposed to say, the interval for t as well, the limit for t. Okay, so for this one, if you check, you're going to get this limit. So for C2 now, C2 is going to be 0 up to 1. Okay, so now x is changing, right? So x is now is equal to negative 1 plus t power of 3. So ds equal to square root 38 dt. Okay, so if you expand it, okay, and then integrate as normal, okay, so you're gonna get that for this one is gonna be square root 38 for this part. This one is correct or not? Sorry, it's negative square root 38. Okay, so over here, if you solve it, okay, so it's gonna be c for x to the power of 3 ds is equal to c1. Okay, c1 plus c2, right? So for this one, it's gonna be 0 plus negative square root 38. So it's gonna be negative square root 38 as the final answer for this one. Wait, yeah, because this one just involved with two curve, right? So you just need to add for the C1 because we got 0, so that's why we got 0 over here, and C2 is the previous answer that we calculate. Okay, so that's how you get the final answer for this one. So you can imagine that if you have more curve, means that more I'm supposed to say more calculation need to be done, okay, in order for you to solve for that one. But technically, that's how you solve, okay, for the line integral whenever you have a piecewise smooth curve, no matter how many curve that you got. Okay, that's all for this video. Thank you.